Half-track vehicles. Half-track vehicles in World War II were built to move troops and equipment across terrain where normal trucks could not operate reliably. They combined front wheels for steering with rear tracks for traction, handling mud, snow, and uneven ground better than wheels alone. Structurally, this design let them follow armoured units while using simpler automotive systems than full tracks. Armies used half-tracks to transport infantry, carry heavy weapons, and support frontline operations. Their strength was versatility, balancing mobility and load capacity better than wheeled vehicles. Their weakness was protection, since armour stayed light and exposed to heavy fire. Germany relied heavily on vehicles like the SD KFZ 251 during World War II. Half-tracks worked best when mobility mattered more than protection, bridging the gap between trucks and tanks. Armoured cars. Armoured cars were wheeled combat vehicles built for speed, not endurance. They used light armour and strong engines to cover long distances on roads and firm ground. They relied on wheels instead of tracks, which made them faster, easier to maintain, and better for long patrols. That made them ideal for reconnaissance, route security, and carrying messages or commanders between units. Their strength was mobility, allowing commanders to gather information and react quickly across wide areas. Their weakness was protection. Rough terrain limited where they could go, and heavy weapons could destroy them easily. Germany used vehicles like the SD KFZ 234 Puma, while the United States relied on the M8 Greyhound during World War II. Armoured cars worked best before major battles started, when information mattered more than firepower. Armoured personnel carriers. Armoured personnel carriers were built to move infantry safely, not to win gunfights. They offered limited protection from small arms and shrapnel, just enough to survive getting into the combat zone. Structurally, they focused on internal space for soldiers, basic armour for survivability, and enough mobility to operate near the front lines. This let infantry ride forward under protection, then dismount and fight on foot alongside tanks and other armoured units. Their strength was protected transport, reducing casualties while troops were moving under fire. Their weakness was combat power, with weapons and armour that were not meant for sustained fighting. In World War II, vehicles like the American M3 half-track filled this role. Armoured personnel carriers worked best when infantry needed protection while moving, not a vehicle to fight from directly. Reconnaissance vehicles. Reconnaissance vehicles, also known as scout cars, were built to find information, not fights, in World War II. Their job was to move ahead of the main force, observe enemy positions, and report what they saw back to commanders. Structurally, they favoured speed, range, and good radios over heavy armour and large guns. This let them move quickly through roads, villages, and open terrain while avoiding direct contact whenever possible. Armies used scout cars to track enemy movements, check which routes were safe, and keep a clear picture of the battlefield. Their strength was information, giving larger units what they needed to plan and react. Their weakness was vulnerability, since light armour offered little protection once they were spotted. The United States used vehicles like the M8 Greyhound in this role during World War II. Reconnaissance vehicles worked best when they stayed unseen, shaping the battle without becoming part of it. Self-propelled anti-aircraft vehicles. Self-propelled anti-aircraft vehicles in World War II were built to protect moving ground forces from enemy aircraft. They mounted anti-aircraft guns on armoured or semi-armoured vehicles so they could keep pace with advancing troops, unlike towed guns that had to stop and set up. Structurally, SPAA designs favoured rapid turret rotation, high rates of fire, and good visibility instead of heavy armour. This let their crews react quickly to low-flying aircraft during attacks. Armies also turned them against lightly armoured ground targets when there were few enemy planes in the sky. Their strength was mobility, bringing air defence wherever frontline units moved. Their weakness was vulnerability to heavy weapons and high-altitude aircraft that they could not easily reach. Germany used vehicles like the Wirbelwind for frontline air defence in World War II. SPAA worked best when guiding mobile units under constant threat from the air. Prime movers. Prime movers in World War II were vehicles designed to tow artillery pieces, heavy equipment, and ammunition across the battlefield. They existed because large guns were too heavy for their crews to move alone, especially through mud, snow, or broken ground. Structurally, these vehicles favoured strong engines, high torque, and durable suspension over speed or armour. This let artillery units pull their guns into position, then relocate them as the front line shifted. Prime movers were essential for keeping fire support responsive and in the right place at the right time. Their strength was pulling power and reliability under harsh conditions. Their weakness was vulnerability, since they were lightly protected and needed escorts for safety. The Soviet Union used vehicles like the STZ-5 extensively during World War II. Prime movers worked best behind the front lines, where moving guns mattered more than fighting directly. Light utility vehicles. Light utility vehicles in World War II were built to handle many small but essential tasks across the battlefield. They carried personnel, messages, light equipment, and supplies quickly between units. Structurally, they emphasized simplicity, reliability, and ease of maintenance rather than armour or firepower. This made them easy to operate in large numbers across roads, tracks, and open ground. Commanders used them for liaison work, reconnaissance support, medical evacuation, and short-range logistics. Their strength was flexibility, since one vehicle could fill many roles. Their weakness was protection, leaving crews exposed to enemy fire. The United States widely used the Willys MB Jeep in this role during World War II. Light utility vehicles worked best where speed, access, and coordination mattered more than combat strength. Transport trucks. Transport trucks in World War II were the primary logistics vehicles, moving troops, ammunition, fuel, food, and equipment across long distances. They were known as soft-skin vehicles because they carried no armour, focusing instead on load capacity and mechanical reliability. Structurally, these trucks used simple designs and sturdy suspensions to operate continuously on roads, dirt tracks, and supply routes. Armies depended on them to sustain daily operations and keep momentum at the front. Their strength was volume, allowing large quantities of supplies to move efficiently. Their weakness was vulnerability, leaving crews and cargo exposed to enemy fire. Germany relied heavily on vehicles like the Opel Blitz to support its forces during World War II. Transport trucks worked best when supply routes stayed maintained and protected over time. Motorcycles and combination bikes. Military motorcycles in World War II were used to move people and messages quickly across the battlefield. They existed because armies needed fast, low-profile vehicles that could operate where trucks were unnecessary or impractical. Structurally, motorcycles emphasized speed, fuel efficiency, and mechanical simplicity rather than protection. Combination bikes, fitted with sidecars, allowed the transport of passengers, radios, or light weapons. These vehicles handled communication, reconnaissance support, and escort duties. Their strength was speed, letting information travel faster than foot or horse messengers. Their weakness was exposure, leaving riders with no armour against terrain and fire. Germany used motorcycles like the BMW R75 extensively during World War II. Motorcycles worked best when rapid movement and communication mattered more than survivability. Engineering vehicles. Engineering vehicles in World War II were built to modify the battlefield rather than fight on it directly. Their role was to clear obstacles, build crossings, repair damage, and support movement under combat conditions. Structurally, these vehicles were adapted from existing armoured or tracked platforms and fitted with specialised equipment, dozer blades, cranes, mine-clearing devices, or bridge-laying systems. This let armies push through terrain that would otherwise stop vehicles and infantry cold. Their strength was enabling mobility and access, turning impossible ground into usable routes. Their weakness was specialisation, making them slow and vulnerable while working. Britain used vehicles like the Churchill AVRE for assault engineering roles during World War II. Engineering vehicles worked best when overcoming terrain and obstacles mattered more than direct combat. Amphibious vehicles. Amphibious vehicles in World War II were designed to operate on both land and water without modification. They existed because military operations often required moving supplies and personnel across rivers, flooded terrain, or coastal waters where bridges and ports were unavailable. Structurally, these vehicles used sealed hulls, propellers, or water jets, while retaining wheels or tracks for land movement. This allowed them to transition directly from water to shore and continue inland operations. Their strength was flexibility, reducing reliance on fixed crossings and infrastructure. Their weakness was performance, since they were slower and less protected than vehicles designed solely for land combat. The United States used vehicles like the DUKW extensively during amphibious operations in World War II. Amphibious vehicles worked best when maintaining movement across mixed terrain mattered more than speed or armour. Landing vehicles. Landing vehicles in World War II, commonly known as LVTs, were built specifically to carry troops, vehicles and supplies from ships directly onto hostile beaches. They existed because conventional boats could not cross surf zones or keep moving once they reached shore. Structurally, landing vehicles used track propulsion with buoyant hulls, allowing them to move through water, climb beaches, and travel inland without stopping. This made them essential during amphibious assaults, where speed and continuity were critical. Their strength was direct shore access, eliminating the need for ports or docks. Their weakness was protection, with light armour and limited firepower. The United States used vehicles like the LVT-4 extensively in the Pacific during World War II. Landing vehicles worked best when forces needed to move seamlessly from sea to land under fire. Armoured recovery vehicles. Armoured recovery vehicles in World War II were designed to retrieve damaged or immobilised armoured vehicles from the battlefield. They existed because tanks and other armoured vehicles were costly and often repairable if recovered quickly. Structurally, armoured recovery vehicles used tank chassis, but replaced main weapons with winches, cranes, towing equipment and reinforced hulls. This let recovery crews operate close to combat areas while keeping basic protection from small arms and shrapnel. Armies used them to tow disabled tanks, clear blocked routes and recover equipment for repair. Their strength was preserving armoured power by returning vehicles to service. Their weakness was limited offensive capability, since they weren't built for combat. Vehicles like the Sherman-based M32 filled this role during World War II. Armoured recovery vehicles worked best when maintaining operational strength was the priority. Self-propelled anti-tank vehicles. Self-propelled anti-tank vehicles in World War II were built to destroy enemy tanks using mobility and firepower rather than heavy armour. They existed because towed anti-tank guns struggled to reposition quickly as armoured battles became more fluid. Structurally, these vehicles mounted powerful anti-tank guns on lightly armoured, often open-top chassis derived from existing vehicles. This reduced weight and increased speed, letting crews relocate rapidly and engage from favourable positions. Armies used them primarily for ambush tactics and mobile defence rather than direct assaults. Their strength was the ability to strike enemy armour quickly and then withdraw. Their weakness was protection, since thin armour and open fighting compartments left crews exposed. The United States used vehicles like the M18 Hellcat in this role during World War II. These vehicles worked best when speed and positioning mattered more than armour. Rail armoured cars. Rail armoured vehicles in World War II were designed to protect rail lines and provide mobile firepower along fixed transportation routes. They existed because railways were vital for moving troops and supplies, and frequent targets for disruption. Structurally, these vehicles were built onto rail carriages and protected with armour, mounting machine guns, cannons, or artillery, depending on the role. This allowed them to patrol long stretches of track while supporting ground forces nearby. Their strength was sustained firepower combined with long operational range along rail networks. Their weakness was dependence on intact rail lines, which restricted movement and flexibility. The Soviet Union operated armoured trains like the NKPS series during World War II. Rail armoured vehicles worked best where controlling and defending rail infrastructure was essential to operations.